Okay, for today, we're starting with just a review of yesterday, and we've got this function, which has been given to you. It's called f of x, and it's got these starting points. And then, if we do this to it, we take f of x and we subtract 2, the whole thing moves where? Down 2. So the 4 starting points are now changed. Instead of 8, 9, if I move it down 2, does the x of that change? No, it's still 8. If I move it down 2, the 9 goes down 2, and it becomes 7. Who had 8, 7 on your list? Okay, good. So then 1, 1 turns into 1, negative 1. Went down 2. This one becomes negative 3, go down 2, and that becomes 3. And negative 6, and that goes down 2 to negative 5. Are you with me on that kind? Cool. Now that's the easy kind, because we messed with the y values, and then it does what you would think it would do. Now I want you to leave the original points as the original points, but we're going to make a new change. This time, we're going to take our function and do f of 3x. No, 4x. F of 4x. Well, it used to be 8, 9. It won't be anymore. And some poor kid is going to think I just said to multiply all the x's by 4. But I didn't. Are you supposed to multiply all the x's by 4? No, you're supposed to... What does this tell you to do? Talk to the kid next to you and see what you think you're supposed to be doing. Oh. Turn yourself around for just a second. Yeah, I warned that some people would. You don't. All right. I think by now you've got it. Please tell me that you knew we should have divided all of the x's by 4. So then this 8, 9 turns into 8 divided by 4, which is 2, 9. This 1 divided by 4 is 1/4, 1. Notice the y values are staying the same. Negative 3 gets divided by 4, and then the y value stays the same. And last is this one. And the negative 6 gets divided by 4, and the y value stays the same. Now, the only one on that whole list I'd have to, take off some points for on a test would be that. Because you have to reduce if you can. And 6/4 definitely reduces. 3/2. I would have also accepted a decimal. 3/2 is the same as 1.5. Any questions? Now, I ask, what happened to my weird-looking n? Did it get wider? Doesn't it seem like it gets 4 times wider? So then it doesn't. It gets what? Narrower, less wide, 1/4 as wide. Was it a stretch? No, it was a shrink by a factor of 1/4. Let's talk that through again. Make sure you get this. That is not a stretch. It looks like a stretch, but it's on the inside where you don't trust things. That would be a shrink by a factor of 1/4. So that means my n, when I got done graphing the points we just made, you could look at the n's on the same graph would be especially powerful to see it. and you'd see that it was narrower. It was still the same height. Like this point is still the same height, and this point is still the same height, the y value, but it's narrower than it used to be. Okay. Now, what are we doing for today then? If I give you this graph, it is true that you could take a parabola and you could move it to the right, no, to the left 3 and down 4, but you'd have to graph 5 points of the original parabola, and then you'd have to move them all in this way, and then you'd have to move them all again. So I just want to remind you, the fast way to do this, which is what I would want you to do, is to pick some numbers and stick them in, but be strategic. I know some kids are just like, I'm always going to put in 0, 1, and 2. Well, watch what happens when I have this graph and I just stick in 0, 1, and 2. Try putting in 0, square root of negative 7. Doesn't exist. Try putting in 1, square root of negative 6. Doesn't exist. Do you see how you don't want to just always put in 0, 1, and 2? You want to be strategic. So on this one, what would have been a smart starting number to put in? Three wouldn't have worked because the square root of negative 4 still doesn't exist. Yes? 7 would have been a smart number to start with there because square root of 0 works. You know what the square root of 0 is? It's 0. Okay, so back to this one. Don't just put in 0, 1, and 2. What's a good starting number? Strategic. What could you put in here that would make it work really pretty easy? Come on, you know it if you know it. Apparently nobody knows it or nobody's bold enough. Negative 3 would have been a good call to start with. Why? Because that makes this part 0. And then it makes it just super easy to do. All right, put in negative 3 and put in things that are near negative 3, like negative 2 and negative 4. I'd like you to put in those 3 numbers. Is it a law that you have to put in those numbers? No. But do you get that if you put in numbers that go off the graph, I'm not going to take like 2 comma 17. It'll be off the graph. So you want to pick numbers that are going to stay on your graph so you don't want to waste time. So I would pick negative 3, negative 2, and 4. This is super critical. Plugging in numbers and seeing what you get, because then you can get points. Anybody can graph the points. If you don't know how to graph, you probably would have got out of honors by now. Okay, I think you all know how to graph. So do you know how to make the points? That's much more complicated. After that, it'll just be graphing, which will be easy peasy. All right. Remember at the end, though, this is a parabola that has been moved left 3 and down 4. If I had to just kind of sketch it, left 3, down 4, I think it kind of looks like that. But is that accurate enough for an actual test? No, you have to find points. That's what we're doing right now, is we're finding the points. So would you please compare your 3 points to the kid next to you. Wait till they're done. See what they got for negative 3, negative 2, and negative 4. Okay, let's see if you got the same thing I did. I put in negative 3 right here. I'm going to change colors so it doesn't just blend in. And that becomes 0, and 0 squared is still 0. And then I don't forget to minus the 4. Y equals negative 4. Who had negative 3, negative 4? Okay, awesome. Now negative 2 goes in. Negative 2 goes in, and I get 1. 1 squared is 1. 1 minus 4, negative 3. And last but not least, I put in negative 4. Negative 4 plus 3 is negative 1. Negative 1 squared is 1. 1 minus 4, negative 3 again. Some people think that's a problem. It is not a problem. If I actually graph those now, everybody please graph those. And I think you'll see where we are on the parabola. Do you see that those were probably the 3 best points I could have graphed? Here's what some kids do. They put in 0, they put in 1, and they put in 2. Do you get if you have those 3 dots, it's really hard to tell that it's a parabola that's been moved to the left and down. But if you pick the ones that I picked, it'll be way better because you can see where the parabola turns. That's why you want to be strategic. I know people have told you can put in any numbers you want. That's true. But you want to be strategic about the numbers that you pick. All right, let's do another one like that. Let's say you have a square root. First off, do you even know what that looks like? I know some of you have not memorized these yet. You really should. I'm going to show you all 5 that you should just know. Like, I know what that looks like. If you don't, you have a disadvantage. It's like we're in Spanish class, and I'm about to ask you to learn 5 colors. Some kids know 3 of the colors, and you don't know any of them. What's the word for red in Spanish? All right, so you guys got one of them. Right. What's this graph look like? It looks like this. If you didn't know that, you've got a disadvantage. You got to know that that's what it looks like. Okay, because then if I say, oh, now move it to the right. Well, that's easy. -4 means move to the right 4, and then I could just grab it, move it over there. See what I mean? If you know what it looks like. All right, so what are the ones I expect you to know? I'll put them, this is going to look weird, but I'm going to put them all on one graph. That's one of them. You guys know that one? X squared, good. Here's another one. That's that ramp shape. Notice it's going through the point 1, 1. Square root x. Next one, I'm going to use a different color. Absolute value of x. Last one, kind of run out of colors. I got to use yellow, which doesn't show up real well, but who can tell me that one? X cubed, very good. Now, if you want these on different graphs, make them on different graphs. This is your notes. This is you writing it down so you'll remember them later. Now, there's one that I don't want to try to squeeze on the graph because it's really weird looking. Anybody remember what that one's called? 1 over x. And it goes through the point 1, 1 and -1, -1. And it's got asymptotes there and there. So there are the big ones. There's one more that's like so obvious that I'm not saying it, but I probably should just to be really, really sure I've listed all the important ones. It's that graph that just goes up, straight line. Y equals what? Yeah, glad I mentioned it. Y equals x. Famous points like 1, 1 are on there, and 2, 2, 3, 3, 0, 0, -1, -1. See what I mean? Okay, so there's 1, 2, 3, 4, 5, 6 graphs that are parent graphs. You know how many there actually are? Probably infinite. You know how many are important? 12. Those are 6 of the 12 big functions. You really only learned 6 more functions in all of high school. These are 6 of them that you should know. Now, do you get that it could be really complicated to try to remember which function it is, and then also know that I got to flip it, and I got to move it down 7, and man, that would be really hard to do if you couldn't just make an XY chart. I call it your best friend in graphing. And if you didn't know where the parentheses were, that would be really hard. Well, we talked about this. A variable is like an empty parenthesis. There's a parenthesis right there. It matters. The negative is outside of the parenthesis, that was where the X was. You can always put a variable in an empty parenthesis. So now, strategic. Be smart. Is 0 easy to put in? And going to give you a nice easy answer. Yes, that's a good one. And if 0 is good, so are the things that are near 0. Like what? What's just a little more than 0 and just a little less than 0? 1 and -1. Everybody put in those 3 numbers. And compare with the kid sitting next to you. Give them some time. All right, let's see if you got the same things I did. When I put in -1 right here with the parentheses done right, this comes out to -1. Then you put a negative on it, makes it back to +1. +1 minus 7, -6. -1, -6. Raise your hand if you got your negatives right. Okay, cool. If I put in 0, it's easier because the whole thing drops out and you just have -7. And then if you put in +1, it's a little easier because your negative just applies after you cube the 1, which is still 1. Now it's -1. Now it's -8. And there's your 3 points. Who had those 3 points correct? Cool. Now just sketch what it should look like. Do you remember what this graph even looks like? And then where's it flipped? And then where's it moved to? There's 2 critical skills for this. One is getting exact points, and the other is knowing, oh yeah, it was kind of a squiggly shape that got flipped and then moved. So here's the original squiggly shape. Then it got flipped. This negative here flips that to be like this red line. That's it flipping up and down. And then the red line gets moved down 7, which is kind of like that. Way down there somewhere, it got moved down. And if you actually graph those points that I had, it would have been here, and here, and there. These 3 points. Okay, yes? Exactly. That's why you can't just graph 3. Let me tell you this. If you just had these 3 points, there's like a million things that could have gone through that. So on the test, you're going to be asked to graph 5 points. But you still could graph 5 really dumb points. Let me show you what I mean. This graph's going to keep going like this. What if you only graphed this one, this one, this one, this one, and that one? It'd be like you wouldn't really be seeing the big picture. But if you graphed this one, this one, this one, and another one here, and another one here, then you'd be like, oh, I see where it's going. Plus, you're supposed to know that it's a S shape except flipped. I don't know if that's really an S. A squiggle shape that's been flipped and moved down. So you have to kind of know it's down here. And these points are just locking in exactly where it is. And how many points should you have? 5. Now, for doing practice in a class like this, 3 is fine for practice. But on a test, you're going to have 5 points. There are a couple graphs where it's impossible to get 5 points. And then, of course, I'll accept it if you only have like 4. Because maybe the 5th point will go way off the graph. All right, so here's one more typical question for today. Y equals negative square root of x minus 3 and then plus 5. Now, I kind of know what that looks like. It's a ramp shape that's moved to the right and flipped. I'd probably flip it first. And so here's my sketch of kind of what it should look like. Ramp shape, but then it gets flipped, and then it moves down. No, wait, up and to the right. So it sort of looks like this. I'll make it black. This black one at the end. Exactly where are the points? You have to figure out exactly where the points are, but I bet you it ends up looking kind of like that when you're done. Okay, give it a shot. XY chart to the rescue. It's what I call your best friend in graphing. And again, the kids were like, well, I'm just going to stick in 0, 1, and 2 because that always works for me. It won't. I'll pause for a second while you try to find me. In this case, let's just do 4 points because I think the 5th point will go off the graph. Find me 4 points. Strategic. If you don't know how to start yet, I probably should help you. 3 would be a good place to start. And then you can't just go on both sides of that, because then you get negative square roots again, which the square root of a negative number doesn't exist. So be strategic. I'll pause. Okay, if you haven't already, check with the kid next to you and see, and then graph it. And see if your graph kind of matched up with what we thought it should look like. Check your points with the kid next to you, then graph it. Okay, this would be probably one of the hardest graphing questions on the test. And if it's like a struggle bus for you, you still got time. You still have a couple days to practice this before it actually matters. All right, so I'm going to stick in 3. Why? Because it makes this first part 0, and that makes it easier to find a point. So negative 0 is still 0. Then y equals 5 is what you're left with. So 3 comma 5. So I go over 3 and up 5. Now, I'm still kind of in the back of my mind expecting that it's going to look kind of like that. So we'll find out, because it was a flipped over ramp that got moved to the right and up. All right, but we'll find out. Now I'm going to put in another number. I heard somebody say I'm going to put in 3, 4, and 5, and that was a good start, but 4 for sure works. 4 is a good idea. So I put in a 4 here, and I got square root of 1 is 1. Negative 1 plus 5, 4. 4 comma 4. Over 4. Up 4 instead of 5. You know, I don't really like where I put 3 comma 5. I'm going to make this a little more accurate. Okay, so I'm going to make a dot there. And then a dot there for 4 comma 4. And then as soon as you put in 5, you probably realized, oh crap, that doesn't work, because square root of 2, I'm going to say something kind of outrageous, but I think it's true. The square root of 2, nobody knows what that is. What I mean by that is, we know the concept of the square root of 2, but do you get that it's a decimal that goes on forever and never even repeats? The square root of 2 is not something that you could write out. It would go on forever. It's kind of like pi. Okay, so the square root of 2 is some weird decimal. I could know kind of about where it is because I could get close, but don't try to do the square root of 2, so don't try to do 5. What did work pretty nice? When you put in what? Come on, help out. 7, thank you. When you put in 7, I knew somebody would have tried that. 7 minus 3 is 4, and the square root of 4 works out nice. Some sad kids still think there's 2 answers to that, but there isn't. Square root of 4 is just 2. And then you make it negative 2. And negative 2 plus 5 makes 3. Who had 7, 3 on their list? Awesome. Now, if I graph that one, it kind of locks in that that's where I thought it was going to be. And see how it's kind of a curve going down that way? And that's just what I thought it would do. Cool. All right, now the toughest question of them all. Find its domain and range. Why is that so? Here with me. Find the domain. All right. Domain means from left to right. Will this thing keep going to the left? It will not. Reason? Try putting in 2, for example. You end up with a negative number under the square root. That won't exist, so it doesn't keep going that way. So this point right here, which was on our list, it was 3 comma 5, is kind of informative. It tells us the furthest left that it goes is 3. It touches 3, so it's a bracket. It keeps going to the right forever, infinity. 3 to infinity. Raise your hand if you had 3 to infinity. Awesome. And then the last part is the range. Tons of kids have this written backwards. I want you to look at your answer. Do you have the smaller number first? Whenever you have a parenthesis and 2 numbers in it, the smaller number has to be first. And I get it. People are like, oh, it goes from 5 to negative infinity. But if you write that, you'll see you got the smaller number last. You can't do that. You got to have the smaller number first. So this is actually, the range is the question of what's the lowest it goes to what's the highest it goes. The lowest it goes is negative infinity to the highest that it goes, which is 5, and it touches 5. There, I bet I caught a lot of people on that one. The range is the lowest it goes, which is, it will go to negative infinity. The highest it goes is the y value here, so it goes to 5. All right, I hope that you guys aren't feeling like you have to be perfect yet. That's not till the test, and the test isn't for several days. So if I give you a graph for today, and it looks like this, do you have to know exactly what that looks like? Not right away. Could you kind of give me a sketch, though? Everybody, just get a sketch. You should know what shape it is. You should know it's been flipped. You should know it's been moved. Just kind of, what does that look like? This is a sketch. Sketch. From the sketch, it might be pretty hard to get the exact domain and range because you don't have exact points. So then, if you were asked to give the domain and range, you might want to wait till you got your actual points. Which again, I'm hoping, we've already practiced this enough that you'd be able to go, I'm going to put in 4. 4 would be a smart starting number. And then maybe some numbers on either side of it, like maybe 3 and maybe 5. All right, so what does this look like? I think parabola upside down. That's the first thing I do is flip it. And then I would think right 4 and up 7. Was your parabola something like that? Not that one. And then if you needed exact points, you'd make an XY chart. And then if you needed the domain and range, well, the domain, I can just look at that. Domain is all reals. Negative infinity to positive infinity. Because it goes forever both directions. But the range, I want to know that top spot to get the range, because I need to know how high it's going. But it'd be, range would be negative infinity to something. And I'm going to give you one last pro tip. 4, 7 is on this list because look it. And that's the vertex. And isn't the vertex like the highest spot? If you see these and you start seeing their vertex, you're going to have a big advantage. Let's just show you a couple more. What if I needed to know the vertex of this one? I know the vertex. Boom. You know the vertex? 9, 8. Start seeing that. That's the vertex. But it's negative 9 in there. Do you trust the inside? No. Another way to think of it is just stick in a 9 and what happens? You get 8. 9, 8 is the vertex. It's the key spot. Here's another one. It isn't even a parabola, but you can tell me the vertex. What's the vertex here? Key spot. Come on, what is it? Yes. 8, negative 7. Can you see those? And those are points on your list. I mean, you know, like you have to get an XY chart with a bunch of points. Those are like the best points because they're the, in this case, it's a V shape and I know it's been shifted and I know it's been shifted right and down. So I know it's kind of like that, but where is this? Well, it's at 8, negative 7. Tells you the vertex of it. Isn't that handy? Okay, that's enough for one day. Now your brains are completely full. You've got a worksheet and it's got a bunch of practice problems on it. I'd like to look at it with you and maybe we can pick a couple that I can throw out to make it more doable. Thank you very much. Scroll it a little bit down. Skip D as in dog and then scroll down further. I think we can skip D and E. Dogs and elephants. Skip D and E. Am I saying you are not allowed to do them? Of course, do them if you want. But I'll be okay if everybody skips D and E. What were we doing? I'll show you this now. We were doing something else. Because when I walk your way and you hit the thumb button, I know you're up to something. All right. You got a bunch of time to work now? That's all I have for the video for today.